Okay, so today we're going to factor, right? This demo is a little bit long. And before we start, I'm just going to preface everything with saying factoring means rewriting as a multiplication problem. So you can, whether it's a number or an expression, we want to take that thing that we're given and rewrite it as a product. Rewrite it as something times something else. So it's sort of the undoing of multiplication. So let's multiply 3x times 7x minus 5. Can you guys do that in your head? Do you want me to? It's already up there. How did you know that that was the answer to that? Yeah, so some people learn this where they do 3x times each thing in parentheses, and you get 21x squared minus 15x. Okay. So I can multiply those two things and get 21x squared minus 15x. If I want to undo that, I want to factor. That means take the thing I'm given and write it as a multiplication problem. What would my answer be?
3x times 7x minus 5.
3x times 7x minus 5. So we are factoring today. We're going to learn how to, without being given the first thing, right, how to just look at that and be able to write it as a multiplication problem. Okay, so last class we did this multiplication. Let's do it again. Right? I'm going to multiply 4x squared y cubed by negative 3y squared minus 7x squared plus 2xy. And last class we did this with boxes, right? We took one of the factors, the 4x squared y, and we made it the width. And then for each term, each thing that's separated by a positive, by an addition or a subtraction sign, it gets its own box across the top. So I put negative 3y squared, negative 7x squared, and 2xy along the top. And then you fill in each of the boxes with the area of the box, its length times its width. Okay, so when I want to multiply these two things together, start by multiplying the numbers. Negative 3 times 4 is? Negative 12. Thanks, I almost forgot the negative. X squared times nothing up here. What? It's just x squared, right? Because there's an imaginary 1 hanging out up there. And y cubed times y squared is y to the 5th, right? So we did this problem last class, so let's just finish it. 4 times negative 7 is negative 28. X squared times x squared is x to the 4th. And y cubed times 1 is y cubed. 4 times 2 is 8. X squared times x is x cubed. And y cubed times y is y to the 4th. And there's a plus sign there. So that means that 4x squared times y cubed multiplied by this whole thing, negative 3y squared minus negative 7x squared plus 2xy, this is the result. The things in the boxes is the product. Just add them all up. So now suppose today what we really wanted to be able to do is go in the other direction. I want to be able to give you this, the things in the boxes, and ask you to unbox it, right? What went on the outside in order to get those boxes? Okay, so the idea here is to find the greatest common factor. This is probably something that you've seen at least very briefly in a previous math class. Greatest common factor. Some lucky people can do this just by looking at the terms, right? If you're not one of those lucky people, I've written out in great detail all the steps of how to find the greatest common factor. This might look familiar if you took 095 here, but I'm going to skip down to number 4, and if the details escape you, go back up and read this, okay? All right, so skipping down to number 4 here. Okay. I'm going to do it with boxes. So I put all of the terms of the thing I'm trying to factor in boxes, right? And then I want to pull out a greatest common factor. So first we look at the numbers, negative 12, negative 28, and 8. Are there any numbers that can divide into all 3 of those? 4. Yeah, so I could pull out a 4. Okay, then we look at the x's. I've got an x squared, x to the fourth, x cubed. So how many x's do all three of those terms have in common? An x squared. So I'm going to pull out an x squared. So shortcut, you're looking for the smallest power of each variable, right? So I've got y to the fifth, y cubed, and y to the fourth. Which one can I pull out? Y cubed. You pull out the smallest variable. Good. All right, so that's what we call the GCF, the greatest common factor. So that thing divides evenly into each of the terms that I wrote in the boxes. Then I have to figure out, what do I put along the top so that when I multiply this times this, I get this, right? I have to figure out what goes along the top so I get the products in the boxes. So we think about what's missing, right? So what do you have to multiply 4 by to make negative 12? Negative 3. So negative 3 has to go up there. What do you multiply x squared by to make x squared? 1. So I could put a 1 there, but it doesn't really matter, right? What do you multiply y cubed by to make y to the fifth? Y squared. And I didn't really need that 1 because multiplying by 1 doesn't change anything. So I think I might erase it and just put the negative 3y squared. Good. Then we do it for the next box. Negative 4 times what gives you negative 28?
7.
Negative 7. Yeah. X squared times what gives you x to the fourth? X squared. And y cubed times what gives you y cubed? 1. I could write a times 1 there, but it doesn't change anything, so I'll just leave it. All right, and then the last box, what do you multiply 4 by to make 8?
2.
2. What do you multiply x squared by to make x cubed?
X.
What do you multiply y cubed by to make y to the fourth?
Y.
Y. That is my factorization. I now know that this times this equals what I was started with, what I was given. Yeah. The greatest common, the biggest thing that's common to all of them. So that, if I'm looking for the biggest power of x that is in all of them, you end up looking for the smallest power of x that you can see. So x squared, that's the biggest power that would show up in every single one. The rest of it is up here. Yeah. Yeah. So that's factoring out the greatest common factor. So if I want to be really specific, I'm just going to write this down so to be really clear about what we're doing. I took negative 12x squared, y to the fifth, minus 28 x to the fourth, y cubed, plus 8 x cubed, y to the fourth. Right? That's what I was given. That's what I started with. And I factored it, which means I rewrote it as a multiplication problem. And these two things I circled in green are my factors. I rewrote it as 4x squared y cubed times negative 3y squared minus 7x squared plus 2xy. So factoring means rewriting as a multiplication problem. Questions so far? Okay. All right. So I'm just going to skip down to number 7. All that's written here is just the details of exactly what we just did. It's not actually skipping anything. I just said it already. Okay. So number 7. So now we can see that this long thing that I was given can be written in factored form. Right? So I factored it. The process of turning addition and or subtraction into multiplication is called factoring. And the special kind of factoring that we just did is called factoring out the GCF, the greatest common factor. So here's one that's a little tougher. I've got negative 2x cubed plus 8x squared plus 24x. So I took what I was given here and I wrote it in 3 boxes. negative 2x cubed plus 8x squared plus 24x. I'm going to start by factoring out the greatest common factor, the GCF. So what number can go into 2, 8, and 24? 2. So I'll pull out a 2. And then what is my greatest common factor of x cubed, x squared, and x? X. And then that's all I have. There's no y's. So I'm pulling out a 2x here. And then we have to figure out what goes along the top so that when you multiply the terms on the top by the 2x, you get the terms in the boxes. Okay, what do I multiply 2x by to make negative 2x cubed? It definitely needs to be negative, right? Because here I have a positive 2, and in the box I have a negative 2. So for the numbers, I need a negative 1. Yeah. So I'll write negative 1. Okay, and then for the x's, what do you multiply x by to make x cubed? X squared. Yeah. Negative 1 times x squared, we typically just write that as negative x squared, and we ignore the 1, right? So that's what I'm going to do. Just write negative x squared. Okay, what do you multiply 2 by to make 8? 4. Yep, positive 4. And what do you multiply x by to make x squared? X. And that's it for that one. What do you multiply 2 by to make 24? Plus 12. What do you multiply x by to make x? 1. So I could put times 1 there, but I don't really need to because 12 times 1 is 12 times 1 is 12. Yeah. All right. We factored out the GCF. So I now know that I can take what I got, what I was given. I had negative 2x cubed plus 8x squared plus 24x. And I can rewrite it as a multiplication problem where the two factors, the two things I'm multiplying together are 2x and negative x squared plus 4x plus 12. So I took that expression and wrote it as a multiplication problem. Okay. So our job now I want to look at this thing. It's called a trinomial because there are 3 terms in it. Right? 1, 2, 3 terms, so we call it a trinomial. I want to take that trinomial and I want to factor that even more. Okay, the problem is there are no common factors, right? If I look at the numbers, I've got 1, 4, and 12. What's the GCF of 1, 4, and 12? 1. Pulling out a 1 is not helpful. It doesn't change anything. How about x squared, x, and nothing? Nothing, because this guy doesn't have any x's, so I can't pull it out. Yeah. So I have no common factors, so I have to try to do something else, a little bit trickier. Okay. So I'm going to do that using a box, but I'm going to use a 2x2 box this time. Okay. 2x2 box, which is going to make things much tougher. Okay. But not so tough that you won't be able to do it. It's not too bad. Okay, so we begin by putting the quadratic term in the upper left. So I made a 2x2 box, and this is the thing I'm trying to factor. My quadratic term, that's the x to the 2, it goes in the upper left, negative x squared. And then you put the constant term, just the plain old number, you put that in the lower right, the 12. What do you get when you multiply negative x squared times 12? Negative 12x squared. I wrote that right here. That's the product of the diagonal. Okay. So we multiply those two together and we get negative 12x squared. So this is a procedure that's going to work, and it's kind of like, why are you doing that? Right? Like, why are you multiplying the diagonals? Just trust me. It's going to work. We're going to figure out what goes along the top and along the bottom to make the right product. Okay, so now I'm going to list all the pairs of factors of negative 12x squared. All the things you can multiply together to make negative 12x squared. So I could have 1x and negative 12x. When you multiply those together, you get negative 12x squared. 2x times negative 6x, that gives you negative 12x squared. 3x times negative 4x, negative 12x squared. 4x times negative 3x. You guys get the idea? I'm trying to write down here all the different ways I can make negative 12x squared by multiplying two things together. Then I'm going to take the two factors that I came up with and add them together. What's 1x plus negative 12x? Negative 11x. 2x plus negative 6x? Negative 4x, yeah. 3x plus negative 4x? Negative 1x. 4x plus negative 3x? 6x plus negative 2x? 12x plus negative 1x? 11x. Okay. So we wrote out all the factors of negative 12x squared, added the factors together. What I'm looking for, I'm going to look in that list of my list of sums, and I'm looking for the middle term. I'm looking for 4x. Which set of factors adds up to positive 4x?
6x minus 2x.
6x minus 2x. That's the winner. Okay, so the next page gives all the details written out of what I'm about to go through verbally. So if I lose you at any point, know that it's written on the next page. So I've got 6x and negative 2x. Those are the two factors I like because they add to my middle term 4x. I'm going to put them, 6x and negative 2x, in these two boxes that are still empty. So 6x and negative 2x, and I can do it in either one, doesn't matter. You can put the 6x and the negative 2x, or the negative 2x and the 6x, doesn't matter. So I'm just going to plop two of them in there. All right, so that is the tricky part. Now I'm just going to look at just the top row here, and I want to pull out the greatest common factor, right? What is the greatest common factor here? Negative x. They both have a negative, right? So I can pull out a negative, and they both have an x. So negative x. All right, I don't like that I have that circle there. That was negative 2x, and this is negative x. Okay. So that's the next thing. You look at the first row, pull out the greatest common factor. All right, now I have to figure out what goes in all the other spots to create the products in the boxes, right? So what do I have to put here so that what do I multiply negative x by to make negative x squared? Plain old x. What do I multiply negative x by to make negative 2x? It's actually positive 2 because I already have a negative here. If I put another negative here, it would come out positive. All right, what do I multiply? Now I have an x up here. What would I multiply this x by right here to make 6x? 6. And I'm done. A positive 6, right? So I have now factored it. My factors are x plus 2 and negative x plus 6. So my answer, right, I took negative x squared plus 4x plus 12, and I rewrote it as a multiplication problem, x plus 2 times negative x plus 6. So it's kind of a long procedure. Once you do it a couple of times, it'll stick. Okay, so again, all the details of every little step that we just did are written out step by step on the next page here. So I'm actually going to have you skip to 18, right? So remember where we started. Skip to number 18 here. This is what we started with. It was negative 2x cubed plus 8x squared plus 24x. We factored out a 2x, right? And then we wanted to factor this thing in parentheses. We did that using the 2 by 2 box. So we still have this 2x. right? So our final answer is 2x times negative x plus 6 times x plus 2. Okay. All right, I'm going to have you skip to number 20. Okay. Like I said, with practice, using a 2x2 box to factor becomes easy, but it's a tough process to follow at first. Persevere, you will get it. That said, if you know another method of factoring and you don't like the boxes, go ahead and use whatever method you have. I will never require you to use the boxes on any test problem. The important thing is that you are able to factor using some method. So the activity that is coming up is a little bit long. Get through as much as you can, and I will come around and help.